Hello everyone, in the course of this video lesson we are going to be solving this question. I know most of you will be like, during exam, when you see this exam, just like, oh man, I have to skip this thing. Believe me, it's extremely easy. Now the question says, when each of the nitrates of potassium, magnesium and iron are heated, A, all the nitrates decompose to their oxides. B, the nitrate of magnesium gives the nitrite and oxygen. C, the nitrate of magnesium and iron gives the oxide. D, the nitrate of iron gives the nitrite and oxygen. E, the nitrate of the magnesium is not decomposed. Now the only strange thing I will like say it's not really too common is nitrates and nitrites. Oxygen, we all know that oxygen is O2 now, right? Yeah. And nitrites, alright. Nitrite is just NO3 minus, alright. Very easy. I won't say this is nitrates. Let me just write it out. Nitrate. Why NO2 minus is nitrite. Now, in order to understand this question, we have to know what we call thermal decomposition. When we say thermal, heat is being applied now, right? Thermal decomposition of nitrates. Thermal decomposition of nitrates. Now, in thermal decomposition of nitrates, we'll use three families as case study. What do I mean? Now, the first family I'm going to use what we call the alkali metals. Alkali metals. Now in alkali metals, it contains elements under group 1, like we have sodium, we have potassium. But in this case, we are going to use potassium as a case study. Why? Because we are dealing with potassium in this question. Potassium is one of the elements we are going to deal with in this question. Now, what happens in thermal decomposition of nitrates? Now, potassium and nitrates, they'll be chemically combined. Now you know how we got this now. Remember, potassium it tends to lose what? 1 electron. Alright, while nitrate gains 1 electron. 1 1. So is already balanced. Alright. So it's KNO3. Now on the application of it, remember this is a decomposition reaction. It will decompose to what? To what? Various products. Now when potassium nitrate, heat is being applied to potassium nitrate, what will be formed? It will be nitrite and oxygen. I'm not here to balance equations, so don't ask about that. I'm not balancing any equation here. I just want to show you how to answer this question. Now, when potassium nitrate heat is being applied, we give you nitrite and oxygen. Now, take note, in this reaction, no oxide is formed. No oxide is formed, as you can see. When we say oxide, when an element combines with oxygen to form oxide, we have magnesium oxide. Magnesium oxide is a basic oxide. Why do I say so? When metals react with what? Oxygen, they form basic oxides. But when non-metals like sulfur react with oxygen, they form what we call acidic oxides. We have amphoteric oxide behaving as basic and acidic, but that is not the point now. Now, in this case, no oxide is formed. Are you seeing it like potassium oxide? No, only nitrate and oxygen. Now the second point, the second family we are going to discuss is the alkali earth metals, which are the group 2 elements, alkali earth metals. Well, we have magnesium, we have calcium. But remember, we are going to use magnesium as a case study. As you can see, potassium, magnesium. Now when magnesium reacts with nitrate, it won't be MgNO3. No, we don't do things like that. It will be MgNO3 too. Remember, alkali earth metals, they tend to lose 2 electrons and become electropositive, Mg2 plus, alright? And normally we have NO3 minus. Now the normal way to do this is just to do what? Exchange of valencies. This is 2. It will now be MgNO3 2. Or you can say this is 2, this is minus. Now how will I balance it? I'll just put 2 here. So therefore NO3 will be having 2. Why Mg will have nothing? But that is just complicated. Just exchange their valencies and you have this. So I have MgNO3 too. Now when heat is being applied, alright, it will break to magnesium oxide, nitrite, which is NO2, and oxygen. Remember, I'm not balancing equation. I'm not here to teach you balancing of equation. Alright. Now, as you can see, oxide is formed. Right? Magnesium oxide, nitrate and oxygen. But for alkali metals, only what? Only the nitrite and oxygen was formed. Now the last one we're going to use as a case study, transition metals. as you can see, we are going to make use of iron. Now we'll use the one Fe3 plus, the one that tends to lose 3 electrons. Now Fe3 plus, it should now be FeNO3 what? I put 2 here, no nice 3. Remember I told you exchange of valencies. Fe is having 3 points, tends to lose 3 electrons, and NO3 is still minus. When you exchange their valence, it will be MeNO3 2. Alright. Now when heat is applied, we decompose to what? Iron oxide Fe what? 2O3. Iron oxide now Fe2O3. Oh, how many times will I explain this? Now iron has 3 what? Tends to lose 3 valencies. Oxygen, as we all know, is 2 minus. Right. Now when they exchange valence, it will be Fe2O3 iron oxide plus nitrates and oxygen. Sorry, everything is jam packed. Hope you can see it. It's so sorry about that. Now when heat is being applied, we decompose to iron oxide, nitrate and oxygen. What is the message here? Oxide is formed, nitrate is formed, oxygen is formed. For alkali earth metals, oxide is formed, nitrate is formed, oxygen is formed. But for alkali metals, which is the potassium, magnesium, potassium, sodium, no oxide is formed. Only the nitrite and oxygen is formed. Now let's answer the question. A. Now when each of the nitrates of potassium, magnesium and iron are heated, which we have done and brought out the chemical reaction, all the nitrates decompose to their oxide. Is that true? It is not. All the nitrates decompose to their oxide. Only that of alkali earth metals, only that of magnesium and iron decompose to their what? To their oxides. But potassium nitrate did not decompose to its oxide. So A is wrong. Now B. The nitrate of magnesium gives the nitrite and oxygen. They are trying to ask us whether is it only the nitrate of magnesium that gives the nitrate and oxygen. Never. All of them give nitrite and oxygen. All of them give nitrite and oxygen. All of them give nitrite and oxygen. So B cannot be the answer. C. The nitrate of magnesium and iron gives the oxide. Exactly. Potassium nitrate couldn't give us the oxide, but it was only magnesium in this context. It was only magnesium that gave us the oxide and iron that gave us the oxide. So we can say for now C is correct. But let's continue. The nitrate of iron gives the nitrite and oxygen. Sorry, the nitrate of iron gives the nitrite and oxygen. The nitrate of iron gives the nitrite and oxygen. No, it was not only the nitrate and oxygen it gave, it still gave its oxide. It is the same question as B. The nitrate of magnesium gives the nitrate and oxygen. The nitrate of iron gives the nitrate and oxygen. No, it also gave their oxides. Alright, so D cannot be the answer. Then E. All the nitrate of the magnesium is not decomposed. How now? all the nitrate of the magnesium is not decomposed. Is actually decomposed. So E cannot be the answer. So the answer to this option is option C, which says the nitrate of magnesium and iron gives the oxide, as you can see in this chemical reaction. If you like what you see, click on that plus sign to follow me, share this video and make sure you like. And if you are watching this on YouTube, do well to subscribe and hit on the notification bell so be notified whenever I release my videos. Those praying for Jamb 2026 tell me, God bless and stay tuned for more.